Hey everyone, my name is Rishi Patel. This is my Project 3 summary of key learnings for ME-3210 Design and Manufacturing, submitting to Dr. Hassan Rashidi. In the world of design and manufacturing, a wide range of tools, processes, and techniques come together to create everything from everyday products to highly specialized components. Each process plays a unique role contributing to efficiency, precision, safety, and innovation across multiple industries. For manufacturers, the challenge lies in selecting the right methods to optimize productivity and meet strict quality standards, especially in today's competitive technology-driven market. The goal of this project was to choose 5 tools, models, processes, techniques, or strategies that I found the most interesting. The 5 topics that I chose are computer numerical control, which is CNC, lean manufacturing, magnetic particle inspection, rolling, and lastly, abrasive machining processes. CNC and lean manufacturing, for instance, are fundamental for maximizing product efficiency, flexibility, enabling high-precision parts with minimal waste, while magnetic particle inspection ensures product safety by identifying flaws without damaging parts, and rolling and abrasive machining processes allow for the creation of uniform materials at high quality finishes for demanding applications. These techniques not only exemplify the best practices in manufacturing, but also addresses real-world demands like cost effectiveness, safety, and environmental sustainability. Through this project, I aim to highlight each technique's strengths and limitations while exploring why they are invaluable in advancing modern manufacturing. So first I'll start with CNC. CNC technology enables the precise automated control of machine tools which perform operations like cutting, drilling, and milling based on pre-programmed sequences. CNC is widely used across industries due to its versatility and precision. In aerospace, CNC machines produce complex parts like turbine blades and landing gear components, while in automotive, CNC is essential for fabricating engine parts, transmission parts, and also brake components. The medical industry relies on CNC for producing surgical tools, orthopedic implants, and prosthetics that require high precision and smooth finishes. In electronics, CNC is used for PCB drilling and machining housings for sensitive equipment. This is really important technology as it allows manufacturers to produce high-quality parts consistently and efficiently, which reduces manual labor costs and error rates. Its ability to switch quickly between designs makes it invaluable for custom orders and rapid prototyping. Some of the capabilities is that it provides high precision, repeatability, the ability to handle complex geometries, and also it's compatible with a wide range of materials, while the limitations is that it requires an initial high setup cost, requires skilled operators, and also the potential time for complex programming. So next we have lean manufacturing. This is a methodology which is focused on maximizing value while minimizing waste. Lean principles are applied extensively in automotive manufacturing. For example, in Toyota, which by the way is a pioneer for lean manufacturing, Toyota production line uses just-in-time techniques to reduce excess inventory and enable smooth production. In consumer goods, lean practices help companies reduce bottlenecks in supply chains, improving delivery times. Lean is also applied in healthcare to streamline patient care processes, which reduces wait times and improve resource allocation. In the electronics industry, lean practices help manage the complexity of small batch, high mix production environments, reducing the time and cost of retooling and setup. The importance of lean manufacturing is that it emphasizes on reducing waste and improving flow, which allows companies to essentially save costs, increase their product output, and also respond more flexibly to demand changes. Lean has a culture of continuous improvement, which enables these businesses to adapt to a constantly evolving market. So some of the capabilities is that it improves process efficiency, reduces cost, enhances product quality, increases customer satisfaction at the end of the day. While the limitations is that it requires organizational culture change, which can be quite difficult to implement, and also it may require upfront training and investment. I think lean manufacturing is really important, so I kind of want to go over 3 more examples within this principle. So the first one being value stream mapping, which essentially is a visual tool to map out the flow of materials and information in a process, identifying waste and potential improvements. The picture in this slide is actually an example of a value stream map, which goes from supplier to the customer end. And then the benefits is that it helps teams visualize and streamline certain processes, focusing on customer value and reducing waste. And this could also apply to like physical value stream maps, like an assembly line for a manufacturing process. Next is the 5S methodology, which stands for sort, set in order, shine, standardize, sustain. And essentially, this organizes workplaces to improve productivity while reducing waste. And last but not least is Kaizen, which stands for continuous improvement. Kaizen encourages continuous incremental improvements and processes to boost efficiency. And the benefits is that it builds a culture of continuous improvement and engages employees in enhancing processes over time. Next is magnetic particle inspection technique. MPI is a non-destructive testing technique that identifies surface and near-surface defects in ferromagnetic materials. So for example, in the aerospace sector, MPI is used to inspect engine components, landing gears, and also structural parts for cracks or defects that could cause in-flight failures. Within the automotive industry, MPI ensures the safety of critical parts like crankshafts, axles, and steering knuckles. Oil and gas industry relies on MPI to examine pipes, pressure vessels, welding joints, which must withstand harsh conditions. And even heavy machinery manufacturers also use this technique to inspect large, high-stress components like shafts and gears. So this is really important as it is a quick and cost-effective way to ensure the safety and reliability of components without causing any damage, making it ideal for quality assurance. Detecting flaws before components are assembled or shipped helps prevent cost recalls, potential failures, and also safety hazards. So some of the capabilities is that it's effective for detecting surface flaws, it's quick and affordable, and also works on most ferromagnetic materials. And while the limitations is that it only works on those ferromagnetic materials, it can't detect deeper subsurface flaws and also requires trained personnel to interpret results accurately. Rolling involves deforming metal by passing it between rollers to reduce thickness and create uniform cross-sectional shapes. In construction, rolled steel beams, channels, and rebars are essential materials for building infrastructure like bridges, skyscrapers, and also highways. The automotive manufacturing uses rolled sheet metal for body panels, frames, and structural components. Even in shipbuilding, rolling produces large sheets of metal needed for hulls and decks, while appliance manufacturing uses rolled metal for creating durable, form-fitted enclosures for refrigerators, ovens, and other home appliances. Rolling is important because it is critical for mass-producing high-quality, uniform materials efficiently. By creating these materials with consistent mechanical properties, rolling supports industries that demand durable and precision, particularly in construction and heavy equipment manufacturing. Some of the capabilities is that it has high efficiency for bulk production, provides consistent thickness, which allows for various cross-sectional shapes. While the limitations is that it requires costly equipment and setup, it's only limited to cross-sectional shapes, and hot rolling can lead to surface oxidation. Lastly, I'm going to talk about abrasive machining processes. Processes like grinding, honing, and lapping use abrasive particles to remove material and produce fine finishes. Within the automotive industry, manufacturers rely on abrasive machining for producing components like camshafts, crankshafts, and transmission gears. Medical device manufacturing uses abrasive techniques to finish surgical instruments and implants, ensuring high-quality surface finishes and precision required for patient safety. While in electronics, abrasive processes are used for polishing semiconductor wafers and creating smooth finishes on casings and connectors. These processes are invaluable for achieving the exact dimensions, surface finish, and tolerances required for high-performance parts. These techniques are particularly important when working with hard materials or components that must withstand shear and stress. Capabilities is that it produces high precision and fine surface finish, which is capable of machining hard materials and also ideal for finishing complex or high-stress parts. while the limitations is that it can be slower than traditional machining, has high tool wear rates, and also requires careful management of heat to prevent material damage. Disclaimer, this is for educational purposes only. This is simply a project for a college course. I made this video with the best of my knowledge.